10th problem, integral 0 to pi by 2 sin 2x into sin x into dx. Now product is there, so multiply by 2 and divide by 2, half integral 2 sin 2x into sin x into dx, and this can be written as half, here 0 to pi by 2 is there, 2 sin x, 2 sin a sin b is what, cos a minus b, cos 2x minus x is what, x, minus a plus b is what, 3x, 2x plus x is 3x into dx. So the integration is simple integral. Here limits are to be written because they are different integrals. Say integration of cos x is what, sin x minus 1 by 3 sin 3x, open bracket 0 to pi by 2. So now wherever x is there, you write upper limit, wherever x is there in the answer, 0. So this is half bracket sin pi by 2 minus 1/3 sin 3 pi by 2 minus half into, once again go to the answer, wherever x is there, 0, sin 0 minus 1/3 sin 3 into 0 is 0 only. So second bracket completely is 0. So first bracket is what, sin 90 is what, 1, half into sin 90 is 1 minus 1 by 3 sin 270. You know sin 270 value you must remember, sin 0 is 0, sin 90 is 1, 180 is 0, 270 is minus 1. Sin 270 is what, minus 1, and this side is what, 0. So this is half into 1 plus 1 by 3, and this is nothing but 1 by 2 by taking LCM, 4 by 3. So when you multiply 2 cancels, here leaving behind 2 by 3 as the answer. Twelfth problem, integral minus 1 to plus 1 x cubed minus x squared plus x minus 1 into dx. So people feel that this is very simple to integrate, but in the arithmetic people go wrong. When you write 1 and minus 1 and simplify, in the arithmetic, that is what people say, that God made numbers, man made mathematics, numbers would deceive the human beings. So here x cubed is what, x power 4 by 4, minus x squared is what, x cubed by 3, plus x squared by 2 minus x, open bracket, minus 1 to plus 1. This anybody can do it. The only difficulty is with regard to numbers. So this is 1 power 4 by 4 minus 1 cubed by 3 plus 1 squared by 2 minus 1. Now minus, wherever in the answer, wherever x is there, you write minus 1 very carefully. Put a bracket, minus 1 whole power 3 by 3. Now whole power 4 by 4, and then minus 1 whole power 3 by 3 plus minus 1 whole squared by 2 minus of minus 1. Now these brackets carefully simplify. 1 power 4 by 4 is what, 1 by 4. This is what, 1 cubed is 1 only, minus 1 by 3 plus 1 by 2 minus 1. Till now it is fine. Minus 1 power 4 is what, 1 only, 1 by 4 with a minus sign is what, minus 1 by 4. Minus 1 cubed is what, minus 1 by 3 plus 1 by 3, and one more minus sign is there, totally minus 1 by 3. And minus 1 squared is what, 1 by 2, minus sign is what, minus 1 by 2. And here minus of minus 1 is what, plus 1 with a minus sign is what, another minus sign. Here 1 by 4 and minus 1 by 4 cancel, 1 by 2 minus 1 by 2 cancel, and here minus 1 by 3 minus 1, minus 1 by 3 minus 1. So minus 2 by 3 minus 2 the answer is, when you take LCM, minus 2 by 3, minus 6 by 3, and that is nothing but minus 8 by 3. Now, however, you may feel that the problem is simple. The third step, people go wrong in this problem. That is what arithmetic. In the arithmetic, dealing with numbers, you will always commit a mistake. Now, we deal with some four theorems in different integrals. Out of that, fourth theorem is applied to most of the complicated problems. First theorem, integral a to b fx dx is nothing but integral a to b ft dt. How to read this problem? The definite integral will not depend upon the variable. It is a to b fx dx, a to b ft dt, a to b fz dz, a to b f theta d theta, all of them are same. As long as the function is same, limits are same, say the problem will not depend upon the variable. So now we shall take let integral fx dx is equal to gx. Therefore, integral a to b fx dx is equal to gx open bracket here dx open bracket a to b, that is nothing but gb minus dga. By definition, what in the answer of the integration, wherever x is there, put the upper limit, and wherever x is there, put the lower limit and subtract. Call this one as 1. Now, integral a to b ft dt, we take the right hand side, ft dt, and this is nothing but ft is what? Gt only. If integration of fx is gx, ft is what? Gt only. Open bracket a to b. This is nothing but gb minus ga. From 1 and 2, from 1 and 2, integral a to b fx dx is equal to integral a to b ft dt. Similarly, it is also equal to a to b integral a to b say f theta d theta. So, definite integral will not depend upon the variable. That is what first theorem says. At times we use it. Second theorem, when you interchange the limits, you get a minus sign. Say integral a to b fx dx. Now, if you interchange the limits, lower limit to upper limit to lower limit, you get a minus sign. How it is? Let us see. Fx dx. Now, let integral fx dx, we assume the integration of fx as gx. Then, left hand side, you see, then left hand side is equal to integral a to b fx dx is equal to gx open bracket a to b. The answer is gb minus ga. Whereas right hand side is equal to minus integral b to a fx dx is equal to minus the answer is assumed as gx open bracket b to a, and that is nothing but minus in brackets. So wherever x is there, a, that is what ga minus gb. Now when you remove the brackets, you see that minus ga and minus of minus plus gb. So you can write gb minus ga. So left hand side is equal to right hand side. Third one is simple. So similarly you can prove it. Similarly, integral a to b, the interval a to b is divided into two intervals, a to c and c to b. Integral a to c fx dx plus integral c to b fx dx. Now once integral sign is there, dx is necessary. So now the interval a to b is cut into two intervals, a, c and c to b. That means what? Go from a to c and then c to b, that is equivalent to going from a to b. This can be, this interval can be, a to b can be divided into number of subintervals. So a to c, c to d and then d to b is nothing but integral a to b, only you get it. Now the important fourth theorem which is used very much in number of problems is this: integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Now we take the right hand side, we come to the left hand side. Integral 0 to a f of a minus x into dx. Put substitution, we use t is equal to a minus x dt. A is a constant, differentiation of constant is 0, minus dx. So minus dt is equal to dx because the problem contains only dx. So integral f of t into dx. Dx is what? Minus dt. Now we deal with here 0 to a is what? Only for x, but your problem is in terms of t. When x is 0, t becomes a. T is equal to a. When x is a, what will happen for t? T is equal to, when x is a minus a is 0, t becomes 0. So the problem was 0 to a, so now the problem becomes a to 0. Now we have seen by second theorem, if you write the lower limit as the upper limit and upper limit as the lower limit, you get another minus sign. That minus sign and this minus sign neutralize each other, and so 0 to a f t dt by second theorem. Now by first theorem, if the problem is 0 to a f t dt, the definite integral will not depend on the variable event. You can write t dt or z dz or x dx. So you can write 0 to a fx dx, which is nothing but left hand side. So we have used this first theorem as well as second theorem and to prove the fourth theorem. And fourth theorem is very essential to work out slide.